All right. Welcome everyone who's dialed into this webinar. Hopefully both Jeff and Shalene, you don't mind turning on your cameras. Hey, Jeff. Shalene's arriving. And today we'll be talking about basically AFFF being phased out, right? And a new milspec having been released. So a different foam, which has much less PFAS in it that we, from some point on in time, we'll start using instead of the old PFAS containing foam. Before we get started with the webinar that you see the questions for here, real quick advertisement of the next one, which will be on May 3rd. If you're also interested in knowing how we can treat PFAS in pretty high concentrations in soil, we'll be covering that in the May 3rd webinar. And so we hope to see most of you again for that in about a month from now. So, but today, the topic is essentially this foam transition. And I will stop sharing my screen so we can see each other and simply start by asking you guys the first question on the list. This new foam, this F3 foam, does it have any PFAS in it?
I'll start with that, maybe, if you don't mind, Jeff. So I think when we refer to new foam and new fluorine-free foam, we have to just take a step back and maybe get a common ground as to where we're at as a collective on what that is. So fluorine-free foams have actually been around for more than 20 years and in use. So when you're approaching the subject, you really want to first narrow down the focus in terms of, once you have that arena of fluorine-free foams, know and understand that they're not all created equally, and that they are specified and certified based on the type of industry. So we have the DoD and the FAA that follow the DoD milspec in sort of one bucket. And then we have the everything else category that follows several other types of performance standards, certification, and specifications. So with the new news of DoD having a new milspec that just came out here, milspec 32725, it's called, in January. That one is the fluorine-free milspec. So in terms of what that milspec is, there are not yet, the next step in the process is to certify foams under that milspec so that they can then be used. That should happen here in this next month. Starting this next month, we're going to see certifications coming out of foams. The DoD is looking at, I think, around a half a dozen foams were in the lead across a handful of manufacturers that are already in the marketplace, already have fluorine-free foam mil specifications. So when we talk about that fluorine-free foam milspec by the DoD, what they are stating in that milspec is PFAS is not intentionally added to the concentrate. However, they are permitting 1 part per billion of PFAS as an unintentional component of the foam. So long way to answer your question. That's the DoD perspective. And just quickly on the everything else category, the specification that seems to be rising to the top in terms of permittable PFAS is green screen. And green screen permits 1 part per million of unintentionally added PFAS.
So 1,000 times more.
Yes.
Yes. So the one, yeah. So the one part per billion is 1 microgram per liter total PFAS in the so-called PFAS-free or fluorine-free foam.
Yes.
And that some people think, oh, they're not really doing anything because they still allow PFAS, but we probably should remember that 1 part per billion, that's like 100,000 times less than what it has now, right? And AFFF has 1 to 6% PFAS. So it's enormous restriction in the amount of PFAS allowed. It'll be almost nothing compared to what we were using in the past.
Absolutely. And I think the devil's in the details, you know, when you look, as with anything, but when you look at the DoD milspec and the requirements of that 1 part per billion, it's based on EPA method 1633 and a handful of analytes under that method. I say handful, it's I think up to 40 now. But when you look at the green screen and that 1 part per million, it's actually total organic fluorine. That is the measure. So not only do we have variability in what those things are allowing, we have variability in how it's measured. And just to be clear, the green screen is not a certification like a milspec certification. It's more to help a user procure foam that is environmentally friendly as possible. So it's not in and of itself a specification like a milspec.
And the total fluorine methodology doesn't necessarily mean that it's PFAS. It just means that it's a kind of a just a marker to determine whether there's significant fluorine, which then could mean PFAS. And again, the key to the whole thing is no intentionally added PFAS. As Shalene mentioned, these foams have been around for a long time, but they've had to be revised and perfected in order to meet the milspec. The milspec being kind of the gold standard for the world. Previously, the milspec didn't differentiate between kind of on land use and at sea use, and so the revised milspec does that, which now opens the door to these fluorine-free foams. And so we'll, you know, as Shalene said, within the next several months, we're going to start seeing foams that are going to get approved under the milspec, or we expect.
All right, that helps answer one of my other questions. Is essentially, so are they going to be available? Let's say you had 10 fire trucks now and you were ready to get them all cleaned out and transitioned. Is there a place to go and just buy the buckets of this new stuff?
So once it's certified, the manufacturers have already started ramping up. As I said, it's the primary manufacturers, the major players in foam production globally. There's just over a dozen or so that are really leading the pack. And I think only a handful of them that are actually going through the certification process initially. One is National Foam, and National Foam 2 years ago now in January 2021, they identified they had completed an expansion of their fluorine-free foam manufacturing line to accommodate demand. I suspect other manufacturers are doing the same, but accommodate the demand is, I think, a bit of an unknown, depending on how this will roll out both in the US and globally. If you look at market industry reports, you're seeing they're predicting from 2021 to 2030, a $1.25 billion expansion in just that foam industry. So, you know, I suspect many of the other major players like National Foam are expanding their ability to serve and have it at market and to market. And the other quick thing I would note is those that are trying to get certified right now, they had these fluorine-free products already in a commerce space. They're tweaking formulation to try and meet the milspec.
So, you know, and it's a complex question because number one, the demand is going to be significant. You've got, you know, firehouses all over the country, the DoD, airports, other manufacturers in the refining industry, chemical industry. I mean, there's going to be a huge demand, not only in the US, but Canada and probably around the world for these foams. So you're going to have a huge demand. At the same time, we have states that have developed laws which basically have said for refineries or airports or others, as soon as there is a fluorine-free foam that's approved by the federal government, then you're going to have a limited amount of time to switch over. And the question is going to be whether the manufacturers are going to be able to provide that, or whether those states are going to have to create exceptions, or what's going to happen. But it's going to be a little bit of the Wild West. FAA has indicated that they're not putting a timeline on when airports necessarily have to switch over, but that's FAA, not the states or the local regulators or others that may make demands on users of foam, believing that, well, there's a fluorine-free available, you should be forced to use it as soon as possible. It's not quite that easy, and it's not going to roll out that easily across the country.
Yeah. To Jeff's point, Gorm, I was just going to add that two things to note. One is that the milspec that has come out, right in the milspec, it identifies that they anticipate they will be changing and updating the milspec. They were not able to accommodate compatibility in that milspec, which is a substantial challenge as it pertains to anyone procuring and using foam. That was one of the beauties of the AFFF milspec, is that any foam that you used that was milspec certified was interchangeable. The second part I would just add to that is that DoD has invested a substantial amount of money, millions of dollars, in R&D of replacements, and they have, I think, 36 projects going on right now around replacement alternatives on top of what's already getting certified. So I anticipate that the milspec will change, and I also anticipate that new foams are going to come online as DoD's research starts wrapping up here in the next couple of years.
Well, what I heard you say is, yeah, you can't.
I was just going to say, I saw there was a question about whether facilities that didn't have to comply with the milspec before, what's their status? And you're right, those facilities that didn't have to comply with the milspec but wanted the best foam, for instance, a refinery, they could have switched along the way. That's kind of a risk analysis that they're going to have to do. I do a lot of work in the airport industry, and a lot of hangars were not required by the federal government to meet the milspec, and yet various insurance companies would say, hey, you'll get better rates if you use the gold standard of foam. So all of those entities could have switched over to fluorine-free over the past several years along the way. I think it's going to raise another question we're going to get to, and that is, okay, it's not just so easy to switch over. What do you do about the existing delivery system that's had fluorinated foam in it? And but I wanted to at least touch on that one question that came up in the Q&A.
No, that's very good. So what I was about to say is, so these new liquids that are fluorine-free or F3, they don't mix with each other. Is that what you're saying, Shalene? You can't have, a little bit left over in a bucket from last time, and then you buy another one. If it's not the exact same foam, you can't mix the two, or it doesn't work. If you put them in the foam tank, you could have.
Yeah, that's my understanding. So the foam in of itself will meet the mil specification performance requirements for burn back and other performance metrics, but it does not have compatibility with other individual products.
Because that was a thing with the old AFFF, and I'm showing some of it being removed here from a foam trailer. Hopefully you can see my screen. This was the old AFFF concentrate, right? And this is some of what we've removed from vehicles. And as I understand it, when you were, let's say you dumped some out because it was getting old like this, you could put new AFFF in, and it didn't have to be the same formulation. It would still work, and it goes through your Venturis, and everything was fine. But what I'm hearing is, even to do a transition, how clean do we need to make the systems and the vehicles that had AFFF in them before? If they're not brand new systems, they will have this stuff in them, like I'm showing on the screen, right? So it's quite important what rinsing process you have to go through when you want to use the new foam. And that's basically the next question: how clean do we have to make the stomachs of these fire trucks, the internals, the tank, the venturis, the pipes and pumps? How clean do we need to get them? And one interpretation I've run across, I'm not sure it's right, but has been that what comes out of a fire truck has to be just as clean as what the new milspec maximum allowed PFAS content is, the 1 part per billion. But I don't think that's not what the milspec says. It just says this is what we will allow in this foam concentrate. It doesn't say anything about how clean you have to make the vehicle or the system you're putting it into. And that's a problem, right? Because then how does one state know and another state or another client know how to get the old stuff out and how clean is acceptable?
Yeah. I agree with you. The milspec doesn't say that, but the milspec wouldn't say that because it's a performance specification for foam performance and use, right? But it is the burning question that we've talked about many times before, we'll continue to talk about, and it comes down to, what Jeff has been alluding to is a risk management decision around what's your philosophy from a risk perspective on how you want to manage it, because these criteria simply do not exist. So if you look at the buckets that I've identified, with DOD and sort of what we're seeing with DOD, DOD is right now trying to procure consultants to support their transition and planning. In their request for proposal, the only thing they really say is a single rinse. So that's sort of where DOD is coming from. You see other industries evaluating it and wanting to do more, or states evaluating it, like Connecticut, Gorm, the great work that TRS has done with Connecticut. And really ultimately coming down to the conclusion that we have to take an approach that's a risk reduction, because we're not going to eliminate PFAS or eliminate the risk. It's going to be there.
So, I mean, it's the key question. It's one of the key questions. If you look to FAA in terms of guidance they're going to give to airports, really they're not. Basically, they're saying it's going to be up to kind of state and local regulators, which makes me nervous, because if you just arbitrarily ask a state or local regulator how clean is clean going to have to be, they're going to start thinking in terms of water quality standards or cleanup standards, or even the new, God forbid, the new proposed maximum contaminant levels for drinking water. That's what they think of in terms of clean. They're not thinking about how the equipment is being used in the setting in which it's being used. So, for instance, at an airport, nobody's going to be drinking out of their fire trucks at the end of the day after they transition over. They're going to be spraying probably, hopefully, only in emergency situations. That's the requirement now. So really the exposure is going to be to firemen that are working the scene, and to anybody from the public that's involved in an emergency in one way or another. Those areas can be cleaned up for sure if it's not perfectly free of PFAS. But again, we want to protect the people involved, firefighters and others. But it doesn't have to be to a level of clean. And remember, the milspec even allows up to 1 part per billion. So anybody looking in the parts per trillion for some kind of cleanup standard, I think, is way off base. It will be parts per billion, and maybe multiple, who knows? It's just there are a lot of issues going on there, and I don't necessarily think the 50 state solution is the best way. I think there are better answers to the question than just deferring to local regulators. I mean, even if you take that to an extreme, there are some states that we can predict are going to have always try to drive the lowest standards on everything, and other states that maybe take a more reasoned approach. Well, the state with the lowest standards going to force all of their firehouses and ARF stations at airports to essentially get new equipment. If they can't meet that standard, that old equipment is going to go elsewhere, maybe depending on other state standards, and then we start creating that kind of have and have not scenario, and I don't think we want to do that either. So I think there are other potential avenues here than really asking the question of how clean is clean, or even leaving that up to regulators.
Jeff, would you agree that, from an environmental regulator perspective, their purview and jurisdiction is to regulate the environment? So the only thing they can ultimately regulate is what's discharged from the system, whether it be, a triple rinse of water or a TRS solution or anything else. They can regulate what that is and where it goes as a waste. And that's about it.
Correct. So when EPA develops, say, effluent limitation guidelines, which are the expression of national best available technologies, they identify processes that lead to the best possible results and the lowest possible discharges. But ultimately, once they set that standard, facilities can meet that standard any way they want. EPA can't prescribe that they do it a certain way or not. So I think what you're getting at is right, that and understand that, certainly at airports and DoD facilities and elsewhere, there's already some contamination around. So you're right. I think the key is don't make things worse. And to the extent that you're controlling pathways off-site, you'll continue to control those pathways. You'll continue to be subject to the regulatory requirements for either water discharges or waste management or whatever. So, maybe it's not how clean is clean. It's what are the best technologies available for getting as much PFAS out of the equipment as possible in a cost-effective way, and then leave it up to the site to manage how they manage the rinse rate, as well as future potential releases of foam that may have some rebound impact from PFAS that was in the truck. I think that's a more practical way to go, which relies on some discretion at the site facility, but ultimately has the checks and balances that any discharge off-site or pathway will be controlled. I think the only thing that misses that I just want to reiterate is, we have to keep in mind the people that are exposed to foam generally, which is the firefighters and others involved in emergency, response. So to the extent that whatever PFAS level is either controlled through a technology or through personal protective equipment or something else, we need to keep them in mind and make sure that whatever we result in may not be regulated by the environmental groups, but from a health and safety perspective needs to be thoughtful.
Yeah, there's a question in the feed here. It says, can we expect the current containers of the fluorine-based foam have to be washed out first before the transition? That's actually a good one. If you don't mind, I'll just share my screen again to show an example of that. Is it share? It's sharing. So yeah, so this is an example of that. There's a foam tank on board here. Your first step is to get the old AFFF concentrate out, and it stops dripping. When it stops dripping, there's still lots of this yellow stuff in there. So if you just put either water or a new foam mixture in there, it would come to a concentration that's like 1,000 times higher than what the new milspec says. So I don't think there's much doubt that one needs to get all the yellow stuff out if possible. Otherwise, it's like having Napple in water. It takes only a drop to contaminate millions of or thousands of gallons. So definitely there's some clean out that needs to occur. What we've done is use a washing machine that we designed and built. It's basically a hot water circulation system. You can use it for just cold water flushing, triple rinsing, or you can use it for warm water rinsing, or you can put a rinsing agent like perfluoride in, and then you can run that through the internals of the fire truck. One thing that we found was if we did triple rinse first, in other words, just water rinsing, which some states are saying that's all we need, or some clients are saying that's all we can afford. What happens is you get some of the mass out, but and you stop and that's it. If you then take a fire truck and you clean it with a warm solution with the perfluoride, what happens is you get this type of stuff out of the internal of the truck and the venturis and the pumps. So this was an actual fire truck that first we did the triple rinse very thoroughly, went to something like 2,000 gallons pumped through the system. Then we hit it, and then all this stuff came out. And this is highly PFAS rich residues that was washed off and dissolved off little nooks and crannies inside the fire truck that would otherwise have been left in there to mix with the new F3 foam. So had you just done water rinse, triple rinse, no matter what the new foam contains, it would have rebounded, it would have picked up 10,000 times more mass from the inside of the fire vehicle. So then the question is that good enough? So if you look at our results, we looked at just running water through, and it's similar, Shalene, to some of what you said, we should look at what comes out to the environment from an event. And this is a measure of that. We ran water through the system many times, and then we measured the PFAS coming out. If you just drained the yellow stuff, the old concentrate, your PFAS concentration in there, these are nanogram per liter, would have been in the 60,000s. You do triple rinse and you get some more out, but your water actually comes to about the same dissolved PFAS concentration, because with cold water triple rinse, you just don't get everything. You have, if you will, NAPL left in the system. It would be the equivalent from an aquifer. So the water that you expose the environment to after triple rinse is just as bad as before, more or less, at least the first couple of times you use the fire truck. Then if you do a warm surfactant enhanced or perfluoride enhanced washing of the internals, and then water, and then more perfluoride, and then water again, our process, you can get all the yellow stuff out, and you can get down to an equivalent concentration in the water that circulates through the system that is actually below the 1 microgram per liter, which is the same concentration as the new foam has for the foam tank content itself. So what am I trying to say here? It's that this is a very, very tight spec for the new foam. And in order for it not just to pick up, 60 times more, we're nanograms per liter here, so this is 60 micrograms per liter. You actually have to do a very thorough job at rinsing the internals. So Eugenie, you asked the question, in our opinion, yes, you need to clean out the old systems. Otherwise, it makes no sense to have such a tight restriction for the new F3.
Gorm, that makes perfect sense. I think what research is also showing is after you get down to that level, over time, there's a rebound effect. And the question is, do we really care what that rebound effect is or not? And I think, my thinking has certainly evolved in this. I think if we can, if it's cost effective to follow the method you just showed, or comparable methods that get you down into that, 1 part per billion range, then I think we go from there and not worry about having to retest trucks and everything else. We can get too bogged down in this transition phase, recognizing that everybody that has one of these pieces of equipment has probably already sprayed AFFF on the ground numerous times. They've trained with it, they've calibrated equipment over years. Many have been forced to do that. So they already have other potential contamination issues they need to address. So let's not suck all the resources out of in this transition phase, so that the airport or the facility, the DoD facility, is ignoring other potential contamination that may need to be, addressed in the near future. So I think there's a very practical solution. It's figuring out what that technology is that's cost effective, and then not over regulating it from there on. Let the system go. If the individual operator wants to continue to test to make sure they're not getting too significant a rebound impact, maybe they'll rinse again at some point in the future. That's up to them. But I think from a perspective transition, there's a lot going on. Let's make it as simple as possible.
Yeah, there's also some foam systems that wouldn't be possible to clean to the level I just showed. We did one with an old fiberglass foam tank that had repairs and glue and resin marks, and that one rebounded like crazy because the walls of the foam tank itself was porous. So that one you couldn't have gotten these nice results from. That was a fiberglass foam tank, whereas these other polypropylene or whatever they're called, hard plastic surfaces, those we can clean out really well like this, but not all of them.
Yeah,
A good point. So some of them, I've even heard someone say, should we just give up rinsing all these old systems out, and instead of using the foam tanks that are on board these fire trucks, should we pull a trailer behind each one with the new foam in a new trailer that never saw AFFF? That's the extreme view, which would be kind of weird if it ended up like that, right? You wouldn't just mobilize a fire truck, you'd mobilize a fire truck and a foam tank. If it was a petroleum fire, that would be more complicated.
yeah, absolutely. And to Jeff's point of, the economic cost benefit, the feasibility of it, and all of the variables you have to consider, it hopefully will not get to that in any capacity in any place. Because to me, that's beyond reason.
Yeah.
Mm-hmm.
There is another very interesting question in the feed, and that is, have new built systems for firefighting actually been tested, that they don't have more PFAS in them than what this milspec allows in the foam concentrate? I don't know if we have an answer to that one. I definitely do not, but it's an interesting question, right? Because those who manufacture these foam tanks and these systems probably don't have this laboratory grade certification that they're a PFAS free environment. Like some of us in the cleanup industry have dealt with that. If you want to sample for PFAS, you have all these restrictions you have to meet with. Your gloves can't be a certain type, and you can't use this and that. When they make these fire vehicles, I doubt that they would satisfy those PFAS free environment things. So
well,
if you yeah, go ahead, Jeff.
I think we can overthink this. And
Yeah.
I don't think it really matters, to tell you the truth. I mean, there's PFAS in rain that comes down. We've already discovered and identified that, and probably above the MCLs that EPA has proposed. There's PFAS in the undercoatings and in the paints and waxes that are used on vehicles. And that'll take a while to work its way out of the manufacturing and other processes. So there is PFAS around, and I think we can overthink what might be in a new truck. I think the idea is we're starting with a new truck with fluorine-free foams, and we're talking as in the key point you made earlier, that whatever, hundreds of thousands of times less concentrated than what we're dealing with today. So it's a major improvement, and it's the right step in the right direction. And if we get bogged down into searching for every little PFAS molecule, then we're just going to spend too much time and energy on this one issue, when right now we have so many PFAS demands and needs ongoing. Another interesting point on the alternative fluorine-free foams, and the question that's been posed to DoD that they're researching is, it's one thing to replace something with another chemical, but to make sure that the replacement isn't as harmful as the original in some other way. So they're analyzing all of the components in the new fluorine-free foams to make sure there's not the, kind of the next emerging contaminant there. So there are a lot of angles on this, and I think we have to be careful a little bit about overthinking it. And I know there's been some questions too about what PFAS may be hazardous wastes or not. Right now, EPA has proposed to name PFOS, PFOA as CERCLA hazardous substances. There's a rulemaking that should be a proposal that should be coming out soon, or a request for information on identifying additional PFAS that also could be regulated by CERCLA. EPA also should be proposing this year a RCRA rule related to PFAS. But right now they're not listed as hazardous substances yet, just been proposed. Some states have identified them under their state hazardous waste laws, but nothing national on that regard.
Yeah. And Jeff duly noted about the new system question. And I think if we take that perspective and the common theme, I think here that risk reduction is the goal versus elimination. You can think about all of the product stewardship and activities that are going on around PFAS right now to eliminate it from commerce in general. Whether, it's the REACH restriction proposal in the UK, or some of the things happening here in the US and the New England states with their product proposed laws and regulations. Just know that we are all doing our best. And I think if you look at it from that perspective, eventually these things are going to come out of the supply chain. They aren't going to be a concern in a brand new truck in terms of evaluating if it's a contributing source.
Another great question is, who would decide what's cost effective? And that's a great question, because we typically turn to EPA, and EPA has been very involved in developing standards and looking at PFAS. And yet what we're really looking at here also is jurisdiction with other agencies, whether it's the Department of Defense or FAA or other entities. So it's a really good question, is who would decide what's cost effective? What would be great, and I know that there's a cross-agency kind of PFAS group that meets of all the agencies impacted by PFAS. It'd be great if we had, again, some national uniformity, both for consistency across the country, but also consistency between the different agencies looking at PFAS. And that's asking a lot. I recognize that, but this is a unique challenge, and we're at a point where we're ready to transition, and that transition is a very good thing. And the more we hold that transition up by bogging down in minutia, as Shalene has indicated, let's get over the initial risk concerns, and then we can tweak things in the future, but let's not get too back down.
To your comment, Jeff, on the national strategy, I see Randy Krause on the call here. He's one that's deeply involved in this, but and I've been on the panel for this project. The NFPA Research Foundation has a firefighting roadmap, and they compiled and did sort of a status of affairs across all fire users. So we had representation, like Randy, from airports. We had representation from DOD. Representation from municipal fire, so try to, and industry, oil and gas representation, try to cover the gamut of fire users. That report was published late last year. That group is now moving forward with sort of phase 2 to start looking at these challenges and issues across fire users. And I think it's the closest thing we'll have to that national strategy and evaluating it holistically as a user perspective, even though there's differences across the individual groups.
And I guess my final comment on that would be, cost effective might be industry by industry. There's also what's called an airport cooperative research program grant out that's up for bid, that is trying to identify the best management practices related to transition. So, it could be kind of industry to industry. But
yeah, absolutely.
An interesting question. So I also see the question about the analytical method for total organic fluorine. And I think what we were trying to say is it doesn't necessarily mean there's PFAS. EPA has come out and said in their presentations on the different methods that the total organic fluoride method or fluorine method is really intended to determine if there might be a risk. A very high number would say, hey, look further. A very low number would say, probably not a PFAS problem here, move on. It's not really intended to determine if there's necessarily a PFAS problem, just how do we do a simple look at something to determine whether there might be a need to look further or not. And that's really the purpose of that test.
I think one of the Randy's questions had also to do with, or maybe it wasn't Randy's, there was a question about what if municipalities add fluorine to the water? Will that somehow interfere with the sampling? I think that's quite important. That's not organic fluoride. That would be inorganic fluoride, right? So it shouldn't interfere with the analysis of organic fluoride.
Mhm.
I'm not touching that one. I'm a lawyer.
Yeah. There's a question from Michael O'Brien, and he asks, is this milspec expected in all the classes of foam, A, B, C?
No. So this specific milspec 24-385 that was out was specific for aqueous film forming foam, or AFFF. And that is intended only for Class B firefighting foams. And no other class.
Okay.
Yeah.
Very good.
There's a question that says that the rebound in new areas causing new environmental problems was not answered. I mean, I think what we're saying is the first step is to determine what are the, again, kind of cost-effective ways of cleaning out existing trucks, if there are ways of doing that. I mean, the alternative was everybody has to buy all new trucks, and that's not a very cost-effective way either. These are very pretty expensive pieces of equipment. But if there's a way of cleaning them out, then I would argue establish what that method is. And I don't believe then that I think we could spend too much time then worrying about rebound 3, 6, 9 months later. And we'd have to assess whether that's really part of the risk associated with the transition or not. And more research probably needs to be done there.
Mm-hmm.
I totally understand that concern. It's the root of everything PFAS, obviously. But when you look at risk, you have to have two things. You have to have the hazard itself, and you have to have a complete exposure route. Those two things together make the risk. When you're using any foam, we now know this is not an inert soap-like liquid that we can dance around in and have foam parties. We know now that it is a hazardous substance, or will be designated as such at some point. And so improving on best management practices from a procurement, handling, storage perspective, but training, and then also use when you have a fire emergency, identifying how you can minimize and mitigate that release when you're responding to an emergency is imperative. And I think that's shifting focus for, many of the user communities that are out there.
Mm-hmm. There's a great long comment by Shannon. I can't read it all at the same time, but one of the topics here is when you change over to the new foam, a lot of times you use existing systems, and there'll be carryover of some of the AFFF, and what do we need to do? One thing this is very complicated chemically wise, but I'd love to share an analogy there. Essentially, this yellowish AFFF concentrate is sticky. It's almost like honey or maple syrup or something like that, right? And sometimes there's crust as well. So my point with all this is that if we need a reasonably thorough cleaning out of the old systems, it's not enough to run cold water through. It's like your washing machine, you forgot to put the soap tablet in and you didn't have warm water, your dishes are not going to be anywhere near clean when you open it up, right? So a process that involves turbulence, temperature, and a rinsing agent like perfluoride, you get what looks to be clean dishes. So you have a system that's relatively clean on the inside. You can inspect it with a video scope camera, and you can make sure you got all the yellow stuff out. Then you at least have a whole lot less carryover from the old foams. And in my opinion, that's not a terrible effort to go through to clean out the old system like that. We're looking at cost estimates of between 3 and 10% in worst case of the cost of a new system. So we're not talking about $1.4 million for a striker truck to be replaced. We're talking about less than 100,000 to do a very thorough job cleaning it out, or 30 to 50,000 for a smaller structural fire truck, instead of a new one for 600,000. So what's cost effective, what's reasonable, I don't know, but I think, spending something equivalent to 5% of what a new fire vehicle would cost to make sure it doesn't spray any more of this toxic may be worth it.
An excellent question that Shannon raises in terms of, from the regulatory perspective, it's one thing to get significant improvement, but that's still not zero risk. And I guess my only point would be, you have to kind of balance that zero risk against the risk of what you're trying to do. You have a fire department that may have a tanker truck on fire on the side of the highway, and we need to get that out. And so how clean is clean may matter, may not matter, but the key is that the fire gets out, and then if you have to clean up later, you can come back and clean up. And I get her point is who's liable for that cleanup. And these are all really tough questions that have to be answered. But we have to balance the risk, not just of the foam itself, but we have to balance the risk of what we're trying to do with the foam and how we're trying to get fire out. I don't know whether in Palestine, Ohio, when they had the train derailment, if they tried to use foam or not on that fire, but and I don't know all the circumstances, but if they were reluctant or resistant to because of PFAS, I think we're finding there are a lot of other potential risks associated with those activities that we want to understand before we start limiting or restricting too much on the PFAS usage or the foam usage, period. Yeah. Even if it's mildly contaminated by the rebound, I don't know. These are all tough questions to answer on an emerging contaminant.
Yeah.
But key is, again, asking those tough questions. So thanks for the question. Wish we had the perfect answer for you.
Very good. Thank you. Shalene, do you have anything to close out with, or should we end it here?
Oh, one thing I'll just say, so, hopefully this at a minimum gives everybody food for thought. But what we have to think about next as professionals in this field, as users, is not only what we're dealing with now, but what are we moving into? Jeff alluded to the fact that, we're moving to fluorine-free foams. Are they regrettable substitutions? Is there a concern? The preliminary studies, I had said at the very start of the call, they are not all the same. They are different. So when you say I'm using a fluorine-free foam, it's not, apple to apple. One fluorine-free foam is not the same as the next in terms of what their composition is and what they have in them. And that's one of the reasons why there's compatibility challenges. So we have to be forward thinking about that as well. And there's a lot of activity and research around looking at the fluorine-free foams as well in terms of their toxicity to ensure that we are on top of it.
Yeah, hopefully they're subject to toxicology testing and, you know, LD50 and all that type of stuff that you figure out what dose does it take to harm animals and plants and us before they are certified.
Yes,
I
yeah,
guess
that's required right in the mil spec. Sorry, Jeff, go ahead.
No, that's an excellent point. And I guess, you know, again, taking a step back and looking at the big PFAS picture, as Shalene is doing, you know, we still have contaminated soils where we have no approved remediation method yet. Gorm, I saw your next webinar will be on research and one method. There are a variety of methods being researched, but we don't have any guidance from our federal EPA on what to do with contaminated soil. I saw a recent article that, you know, the DOD has, you know, has submitted a report to Congress that would allow them potentially to start incinerating again. A lot of questions and issues there. So we have a lot of these ongoing issues that need our focus. And I think what's the positive message here is that the DOD has approved a new mil spec, which is at most, you know, which is 0 intentionally added PFAS and at most 1 part per billion. And let's figure out this transition and continuing to be able to use existing equipment and protect everybody in the process, and then move on to our next biggest challenge, because we got a lot of big challenges left.
I agree. Yeah. Very good. Thank you, both of you. You guys are wonderful panelists, and thank you everyone for the questions out there. And hope to see you next time as well. Thank you so much.
Thanks, everybody. Thanks, Gorm. Appreciate it.
Thank you.
Thank you. Always a pleasure.